Okay, if you look at these two problems, you notice you're taking the derivative of an integral. You see the derivative symbol out front, and the function itself is an integral. And so this is the fundamental theorem, another form, but we saw with the exploration that there's a nice shortcut that allows us to solve this quickly and easily without doing a lot of work, actually. So while this function is not a very common function, you don't see it a lot, it does show up often enough that this shortcut is very valuable. So if I want to derive this function, it's an integral. Remember, all you do is you take the upper bound and substitute into your equation every place you see your variable. So the derivative of this function then would be x cubed minus 5, the whole quantity, to the 4th power. So it's real simple. The nice thing is that the shortcut makes the problem real simple. Let's look at the second problem. Again, a derivative of an integral. And so, again, I take the upper bound and substitute it in. Got to be careful with this one. So this would be the square root of 1 plus the quantity 3x cubed. But remember here, because this function is not just x, we do have to follow the chain rule, and we multiply it by the derivative of the upper bound, which would be our inside function, times 3. And so the derivative would be this function here. So learn to use the shortcut, learn to recognize it, and take advantage of the shortcut when it does present itself. So now let's look at how to anti-derive. And if you notice here, these are all fractions. And the trick to anti-deriving fractions is to actually look at the denominator. Because we know that the derivative of natural log of x gives us 1 over x, where if you notice, the natural log of whatever we're deriving becomes the denominator of our fraction. So whenever we anti-derive fractions, we recognize that the denominator is kind of the key, because that must be what we took the natural log of. So if you look at this one, the derivative of our antiderivative of sine over cosine is, it's got to be the natural log of the denominator, cosine of x. And remember, we don't want to write two equations, we want to just write one. We got to include absolute value in there. But again, we got to follow the anti-chain rule and divide by the derivative of the inside. So in this case, the denominator becomes our inside function. So we're going to divide by negative sine of x, because the derivative of cosine is negative sine. And in this case, the sine x cancels. The negative doesn't. So we are going to include that answer, and again, plus c. So that final answer is negative natural log of the absolute value of cosine x plus c. So when you're anti-deriving fractions, always look at the denominator and take the natural log of that, and then divide by the derivative of the inside. So let's take a look at the next problem. Now this one's kind of written in a way that it makes it look like, it looks funny because the dx is in the denominator. But in reality, this is the same as this problem. Okay, and that's the more traditional way of looking at this problem. So once again, if I use that same process that I was talking about previously, I'm going to look at the denominator and say it has to be the natural log of whatever the denominator is. Okay? Absolute value if I don't want to write two equations. Again, to finish the anti-chain rule, we have to divide by the derivative of the inside. So we have to divide by 5. Well, in this case, there's no number there. Remember, there's a 1 on top. So we just put 1 divided by 5 out front. That's the same as dividing by 5. And again, go to the ocean. So plus c. Okay, so let's take a look at the next problem here. So sort of getting the hang of this. We're always looking at the denominator. And it's the natural log of that denominator. And remember, we've got to put the absolute value in there so that we don't have to write two equations. We can just write one. And then, same principle, we come back up here and say if this is our inside function, we have to divide by its derivative. Derivative here is 2x plus 2. Now, you look at the top and say, sort of related, but not really. But if you look at this, you realize you can factor this and it becomes 2 times x plus 1. And now you look, oh yeah, now the x plus 1's cancel. The dividing by 2 didn't cancel, so we had to account for that by putting the 1/2 out there. Again, go to the ocean, so plus c. So hopefully that gives you an idea of how to attack anti-deriving fractions. Always will involve natural log of whatever the denominator is. And always complete it by doing the anti-chain rule by dividing by the derivative of the inside. And the numerator should do some canceling with whatever you come up with. So hopes that helps as you learn how to anti-derive fractions.